Hello students, today we'll be doing few sums based on trigonometrical identities, trigonometrical complementary angles and trigonometrical standard angles. See the first sum. What is written? It's written if tan A is equal to 1 by root 3, then find all other trigonometric ratios of angle A. So here we have drawn a right angle triangle. We have named the right angle triangle in this way, A, B and C. This angle is angle A. And this is angle C is 90 degrees. So 90 degrees opposite side will be hypotenuse and angles A's opposite side will be perpendicular. So other side will be the base. So it's given tan A is equal to 1 by root 3. We know tan basically is perpendicular by base. So in our figure, it will be BC divided by CA. So if we take a common ratio as x, then BC's value will be nothing but 1x, which is the perpendicular. AC will be root 3 into x, which is the base. And now by using Pythagoras theorem, we can find it out the value of the hypotenuse, which is AB. So it's AB square is equal to BC square plus AC square. So we can find out the value of AB, that is coming to x, which is nothing but the hypotenuse. Now we have to find out the other 5 trigonometrical ratios. Cot A we know is nothing but 1 by tan A. So which will be tan A is given 1 by root 3, so it will be reciprocal of that, it will become root 3. Sin A is equal to perpendicular by hypotenuse, so we are using the value of perpendicular, which is 1x, hypotenuse is 2x, x will get cancelled, so it's half. Sin A we have, cosec A we can easily find it out by making it reciprocal, so it will become 2. Cos A is based by hypotenuse, so it's root 3x divided by 2x, so it is root 3 by 2. And sec A is the reciprocal of cos A, so it will be 2 by root 3. So that is the other 5 trigonometrical ratios. Come to the second sum. Here it is given if 12 cosec theta is equal to 13, then find the value of this. Here in the question it is mentioned, use only trigonometrical identities. Now when it is mentioned by using trigonometrical identities, then you are not supposed to use this method, this ratio, taking common ratio and then finding out the value. If nothing is mentioned, then you can always welcome to do it this method. But if it is mentioned, then you have to go with the trigonometrical identities. That is the formula among the trigonometrical ratios. You are supposed to use that only. So what is that written? It is written 12 cosec theta is equal to 13. So we can write cosec theta is equal to 13 by 12. So we know sin theta is nothing but the reciprocal of cosec theta, so it will become 12 by 13. Now see over here, we need the value of sin theta and we need the value of cos theta. We have cosec theta and sin theta. So we have to find out the cos theta. So we have a direct relation between sin and cos, that is sin square theta plus cos square theta is equal to 1. See, look at that, sin square theta plus cos square theta is equal to 1. So cos square theta is equal to 1 by sin square theta. So cos theta will be root over of 1 minus 12 by 13 whole square, which will give you 25 divided by 169. So it will be 5 by 13. Remember, we are not considering plus minus. I told you in class 10, whatever you will do, the angle will be always in first quadrant. And in first quadrant, all the trigonometrical ratio will have positive value. No, now we have to put the values of sin theta and cos theta over here. So we are using it and then we are getting the answer as 3 by 7. Coming to the question number 3. See what is written? It's written without using trigonometrical table, evaluate. Now without using trigonometrical table means in exam you will be getting from the board a table will be given it to you. There the values of different trigonometrical angles will be written, but remember that will be written in decimal. But trigonometrical table means you are always welcome to use trigonometrical standard angle table. There is no harm in this to use this table. Without using trigonometrical table means not this table. They're talking about the table which will be given you along with the question paper to you. That table you are not supposed to use, but you are most welcome to use this table. So please take care of this part. So here, this is the without using trigonometrical table, evaluate. So what is the sum? Here it is sec 29 divided by cosec 61 degree, and this is the sum. So what we are doing, see, we have to change any one of them by using complementary angle property. So what we are writing, see sec 29 as it is, In place of cosec 61, we can write is cosec 90 minus 29, because 90 minus 29 will give you 61. Coming back to the next, it's cos 2 cos 8 degrees, so 2 cot 8 degrees, so it's 2 cot 8 degree. Then we are writing this cot 82 over here as cot 90 minus 8. Cot 45 degree value by using trigonometrical table is 1. Cot 17 as it is. And then cot 73 we are writing as cot 90 minus 17, which will give you 73. And then over here you will be changing any one of them. So I'm keeping this one same as sine square 38. And this one I'm changing it to sine square 90 minus 38, which will give you 52. So over here, cosec 90 minus theta is sec theta. If I am considering this one as theta, so it's sec theta, that is sec 29 degree. So this 2 will get cut, will give you 1. Over here, cot 90 minus 8, that is cot 90 minus theta, is nothing but tan theta, that is tan 8. Same thing for this, cot 90 minus 17 will give you tan 17. So we are writing that. Same thing for over here also, sine square 90 minus theta will be cos square theta, that is cos square 38 degree. So if you're writing all the values like this, cot 8 is 1 by tan 8 is 1 by cot 8 degree, tan 17 is 1 by cot 17 degree. So this will get cut. You'll be getting 2 plus 1 plus 2 minus 3, that is 0. Coming to the next sum, that is evaluate this, the whole thing. So what we have to do, cosec square 90 minus theta is sec square theta. Here we have tan square theta. Over here we have to change any one of them, so we are changing this one. So what we are writing as cos square 90 minus 42, and here we have cos square 42 degree. Here now you'll be using the standard angle values, that is tan square 30, that is 1 by root 3 is tan 30's value, and then we have to make it square. Sec square 52 as it is, and we are changing this one. So we are changing it sine square 38, we are changing it sine square 90 minus 52. This part, cosec square 70, we are keeping it as it is. Tan square 20 we are changing at tan square 90 minus 70, that way. So see, finally it is coming as 1 divided by 2 into cos square 90 minus theta is sine square theta plus cos square theta, and from here we are getting this. Tan square 90 minus 70 will become cos square 70. So that will give you 1. This is sec square 52 degree, and this is cos square 52. Cos square 52 you can write as 1 by sec square 52. Here it will be a square. So this 2 will get cut. So this is half minus 2 by 3, which will give you minus 1 by 6 as the answer. Now the most important problems which are coming now, that is the proving of trigonometrical angles. So here see, it's 1 minus cos A into 1 plus sec A is equal to tan A into sin A, you have to prove. So see, for proving sums you have to follow few techniques, that you are only can start from LHS, and then whatever given at RHS you have to come over here, or you can start from RHS, you can prove whatever is there in LHS, or you can start doing it from LHS, coming to certain point, the simplest form, and then from RHS also you solve and come to that particular simplest form, and then show both LHS and RHS are equal. Remember, you are not supposed to do LHS RHS simultaneously. This is not allowed in board. So what we are doing here, starting from LHS, is 1 minus cos A, we are not changing it. 1 plus sec A, we are changing sec A as 1 by cos A, and then see, it's 1 minus cos A. If you do LCM, it will be cos A plus 1 by cos A, that is 1 minus cos square A by cos A. So that will give you sine square A by cos A, and then it's sine square A, we can write sine A into sine A by cos A. So sine A by cos A is tan A, and this sine A is there. So we could easily prove the RHS. There are many sums related to this that I will post it in Edmodo. This pages, the picture of this pages, I'll post it in Edmodo, so you can always see to it. Always, if you have any doubt, you can always ask me. Here is one important sum which I want to discuss with you. This one, this is the one. This is very important sum. See, LHS is this, RHS is this. We have to prove. So we are starting from LHS. Remember, it's a special sum. We will be doing in this way only. Otherwise, the sum will be huge. So what we are writing cot theta as cot theta, cosec theta as cosec theta. In place of 1, we are writing cosec square theta minus cot square theta. So here we have cot theta minus cosec theta plus 1. So here we are writing cot theta plus cosec theta, and in this one we are writing this. So we can change it as cosec theta plus cot theta, a square minus b square formula, a plus b into a minus b. And here at denominator we are not changing anything. So from the numerator, if you now take cosec theta plus cot theta common, then what will be remaining over here? Here is 1, then minus of cosec theta, and then minus plus cot theta. So from numerator and denominator, this will get cancelled. So you will get cot theta plus cosec theta. Now cot theta you can write as cos theta by sin theta, and cosec theta you can write as 1 by sin theta. If you do LCM, you will reach to the RHS. This is a very important problem. There are many problems which I have solved for you. I will post the pictures there in Edmodo. You can always see it. These are the sums. So 15 solved problems are there. Along with that, you have to solve sums from your book. All the sums you have to solve because you are doing trigonometry maybe for the first time. So you have to do all the sums. I hope you understood. Thank you so much.